give you a good understanding of probably the primary international standard on cybersecurity and how it relates to other systems. So that's me. The introduction was wonderful. There's a little bit more, basically covering things that were already mentioned. So the 62443, IEC 62443, is the probably most widely known international standard on cybersecurity. It's divided into, let's see, it's 14 different parts. I will not discuss these parts in details, but kind of group them into areas that provide the greatest interest to different sectors. The set of standards themselves start with the definition and terms and concepts that sort of organize the entire standard. There are operations and maintenance aspects of the standard. One in particular that we work quite a bit with is 4-2. This deals with maintenance and service providers and their skills and processes. In terms of system-related development and system integration, there are standards at the system level and also at the procedure and policy level. And for original equipment manufacturers, OEMs, they primarily deal with the 4-1 and the 4-2. These are actual components that would go into either safety or automotive or cyber-related systems. So we do certifications in all these areas. The security levels as identified in the standard are split into basically 5 basic categories. 0 being you don't pay any attention to security. 1, you're not considering, you have some minor protection against casual or coincidental violation or interruption of your system. Security level 2 deals with intentional violation, someone with a low skill set trying to hack into your system. Security level 3 is designed to identify areas of your system which are perhaps subject to hacking or breaches by individuals that may have a little bit higher skill sets. And security level 4 looks at protection against perhaps international or highly sophisticated groups that have extended resources. So in terms of identifying security within your environment, this is one of the first things you'll do. You'll decide what's your target protection level. Do you believe that you're going to have interference at an international level, or is your security relatively minimal and you expect attacks from more unsophisticated attackers, let's say? The V model I've seen here in a variety of presentations. One of the key things that security does is look at your process itself and determine whether or not you follow good processes and well-documented processes within your environment and make sure that they're consistent and consistently followed within the organization. So as one who comes in and assesses organizations, there's a set of deliverables that frequently I'm looking for. So obviously you would start with security requirements, good security architecture design, security risk assessment and threat modeling. In the high-level design phase, you'll want to use good design analysis tools. Threat modeling is a good tool. There are other design analysis tools. But as one who is assessing an organization, these are the specific questions and kinds of artifacts and documents that I would look for. When it comes to the actual coding, we're looking for coding standards, unit testing, any kind of unit testing tools or documentation. Likewise with security integration and security validation testing. So it's key that these documents be available to auditors to assess how well and how consistently an organization is following their internal processes. Now, from the standpoint of doing the actual certification, there are 3 basic aspects of the certification. The one that I just finished talking about was the third one there, engineering processes. But a key part of cyber protection is having functionality which protects the equipment against breaches. For instance, strong authentication and authorization mechanisms, means for dealing with overloading, sometimes referred to as a denial of service kind of attack. But also the other aspect here is network robustness testing. There are tools that throw incorrect commands at communication ports in systems to see whether or not the system or the product itself will respond and still be able to function even though these garbage or incorrect commands are bombarding the communication port. So those are three aspects of it: network robustness testing, the basic functionality of the equipment, and good engineering processes. In terms of robustness testing, you may have heard to this as fuzz testing or penetresting. Typically what happens is there are malformed packets that are thrown at the system, and if the input validation routines within the program are sufficiently robust, they should be able to handle the commands which are appropriate and then toss the ones that are not and still be able to continue to function normally. Storm testing could be something like denial of service testing, where just a lot of commands go in. The key thing in storm testing is to make sure that your software is adequately partitioned such that your communications don't overload the total processing capacity of your device. Let's take something like a logic controller and a process control system. If communications took over the entire bandwidth of the processor, then the processor itself couldn't adequately execute its control logic. So a key part of the architecture then of your system needs to be partitioning and allocation of only a finite amount of resources to communications versus the normal control strategy processing. So storm testing would check for that, check to make sure that you are adequately, that your software still can adequately operate under denial of service type attacks. As with the definition of higher complexity in the security levels, there is additional vulnerability testing or communication robustness testing that has to be done at the various security levels. Not as much is needed at security level 1 as at security level 4. You're going to need more robustness testing, and the standard helps you identify what more means, how many hours of testing, how many commands, and that sort of thing that the system needs to be able to survive. Now, from the standpoint of security protection mechanisms within the system, there are also requirements that the system be able to overcome attacks and be able to recover from faults that occur within the system. And again, these security protection mechanisms become more complex as you move through the higher security level. Examples of the security protection mechanisms basically appear in the way of specific fundamental requirements, what are referred to as the foundational requirements. Those foundational requirements appear in two parts of the standard, one at a system level, one at a product level. These foundational requirements all need to be in place, and there are enhancements, let's say, to those foundational requirements depending on the higher security level. And this describes basically what those are. So the foundational requirements then deal with identification and authentication, use controls, which have to do with users of the system and what they're allowed to do. System integrity, this is maintaining, making sure that the internal and external communications with the device maintain their integrity. Typically encryption type systems will handle that. Data confidentiality, this is a way of partitioning data and partitioning the system such that if someone actually gets into the system, they don't have free access to everything. You partition the system sufficiently to make additional access to other parts of the system more difficult. Restricted data flow, this also has to do with the architecture of how information flows within the system. Timely response to events. If something occurs, you want the system to be able to detect that something goes wrong. For instance, if an internal database is corrupted, You want protection mechanisms built in that will identify the fact that the database itself is corrupted and be able to handle some kind of a correction or recovery from that corruption. And then resource availability is what we spoke about in terms of the robustness testing and being able to operate while the system is under attack, still performance basic functionality. So what these are just counts of requirements within the standard. So at security level 1, there's 10 requirements associated with identification and so on, all in the first column there, and additional requirements that you need to put in place for security level 2, onto security level 3, and onto security level 4. So the standard itself becomes pretty prescriptive and identifies specifically what's needed. So depending what security level you've identified, and probably most of the systems that we certify are at security level 3, just by way of example. We go through all of the security level requirements in the standard and ask specifically how these requirements are met and how they're tested. And if you meet all those for security level 3, that's one part of your security level 3 certification. Now, in terms of looking at processes within the system, 2 years ago, the standard itself converted to identifying processes in terms of maturity level. So roughly 30 years ago, the Software Engineering Institute coming out of Carnegie Mellon in the United States identified something called the security and capability model. This identified various what were referred to as maturity levels, and those now have carried through many standards in terms of identifying just how mature the environment is. So at maturity level 1, basically you have good processes in place, but things aren't well documented. If we assess you at security level 2, it means you have good documentation. All of the steps of your software and hardware processes are well documented. Maturity level 3 refers to you have artifacts that demonstrate that you follow your documented processes, and security level 4 is more of an improving or an optimizing, where you can look at how effective those artifacts were and feed those back into improving your overall process. So actually, to get a certification, you have to be at maturity level 3. This is pretty standard because you not only have to have good processes in place, they have to be documented, and you have to have results. So you have to have things like requirement reviews, you have test documentation, validation documentation. You have to have coding standards in and demonstrate you follow those coding standards. So if you're only running with some of your systems partially documented and you don't have artifacts, those would be things that you would have to put together before we could actually issue a cyber certification for your product. Another example of a process certification has to do with system integration and maintenance of systems. These would be different from product development processes. So these are project maintenance, product and system maintenance processes. So we're working with a number of organizations now on identifying their capabilities as a service and maintenance organization. So those kinds of standards and processes appear in 64432-4. The main one, however, that we use is 4-1, which identifies the processes in actual product development. So for those of you who are making equipment, making systems, and you want a security certification on those, this is probably the main standard that we would assess to. There are a number of documents, a number of articles on good software and hardware processes. The one cited here, I think, is a Microsoft book, so there are lots of books out there that follow those. When the standard authors put the standard together, they referenced many of these kinds of well-known procedures. IEEE has a good standard. The Software Engineering Institute has good recommendations and guidance on software development, and all these kinds of information came together to go into the 4-1. portion of the standard. When you're building a safety system, so this could be safety for process control or safety in the automotive sense, you want to make sure that that safety system, the normal functionality of that safety system, is not interrupted. So the 61508 standard primarily applies to process or safety systems in general. 62443, which is mentioned quite frequently within this conference, is a derivative of that standard and applies safety concepts to the automotive industry, but frequently refers back to 61508. So this is a clause that was actually added to the standard in 2016, and what it specifically said is that you need to do some kind of a cyber assessment on your system. And you notice there about in the middle of the page towards the bottom, 62443 in the notes of the 61508 standard specifically mentions 62443 as the a primary source for doing your cyber risk assessment. An important part of the process of developing equipment is having a good, solid design in place. And one of the things that you do once you partition your product into its various components, you establish a high-level architecture, which then you subdivide into hardware and software components, is doing a hazard and effect study on that architecture. And the way that you do that is you look at each individual component and you isolate and study that component as you have it designed and ask, well, what happens if things go wrong with that? So by identifying things that can go wrong, they're actually referred to as deviations in that product, you can build into your system mitigation for those deviations and help improve the strength or the robustness of your product. Exida happens to have a tool called ArcX, which happens quite a bit with this. The units are part of your overall architecture design. As I mentioned, the deviations are things that go wrong in those units, and mitigations are things that may help you resolve the deviations that occur. So what we've done with this tool is we've been doing this for 20 years. We've codified a lot of the information based on our experience and entered it into this particular tool as default. So you can go through this and say, well, I have this one, and yeah, that deviation makes sense, and that's a good idea for mitigation. So the tool will just help you follow that process of doing an analysis of your design and provide you with a simple means of recording the information. As I mentioned before, there are units, there are deviations and mitigations that are recorded in the tool, and it just basically is a tool which implements really a well-known hazard analysis process, which is used widely in many, many different environments. Here is a specific example of a system, a safety system, that was implemented and did not have adequate cyber protection, so hackers were able to get into the safety system and basically shut it off. Now, I don't believe that anything seriously occurred. In other words, if you have a safety system, let's say, in a process environment that's keeping a tank from exploding, or a safety system that's making sure that in an automotive system, let's say that your braking system is operating correctly, if any one of those systems are hacked into, then you don't have the protection that you would expect or that you've designed into the system. So here's an example of a particular product where hackers actually were able to get into a safety system and shut it down, which meant that the safety protections then that had been designed into the system were not functioning. So they didn't figure out that it was actually shut down. As I say, I believe that in this, they discovered the problem before anything serious actually happened, but it still is a very dangerous situation. You know, if you spend all this time designing your safety system and someone hacks into it and shuts it down, all that work that you've done to put the safety system together has been for naught. So this is where it becomes particularly important to make sure that you follow good processes and make sure that any system virtually at this point is hardened against cyber attacks. And we see them in the news every day. I do a lot of teaching of individuals and teams on cyber, and it really is quite simple because all I have to do is follow the standard curriculum, but each day I just open up my mail and somebody's been hacked into, or some other system has been interrupted, or somebody's gotten into some place, and I'll start out with the class, oh, did you see in the news yesterday that so-and-so was hacked into? So I have examples all the time of where systems are hacked into. And the sad part of it is that if people followed recommendations that are part of the 62443 standard, it would be much, much more difficult to hack into the system. So I can read through the postmortems on these things. So, no, okay, they didn't have good authentication. They didn't manage their input validation well. All things that are detailed and outlined in the standard. People didn't pay attention to it. They got hacked in, and it cost them a lot of effort to recover from that. The certification process, Exida does quite a bit of certification. As I mentioned before, we go through the engineering capabilities, and the process is referred to systematic capability with an environment. We see how well the environment processes are implemented and executed. We look through making sure that there are good mechanisms, they follow the foundational standards, and we do the network testing. And these are just some examples of products. These, I think, have all been certified. Oh, we printed these up just to program. Okay, I guess I was looking for the specific standard. And unfortunately, it's obscured in those certifications. But we have on our exida.com website, we have a whole list of products that have been certified. So if you're curious at all about seeing any of those, you can go to our website. And all the products that we've ever certified, anywhere from individual valves and sensors to LiDAR systems to operating systems. We work closely with Green Hills in certifying their operating system. They're all listed on our website. Now, question here is, who does this certification? Now, OEMs, original equipment manufacturers, can claim that they're self-certified. Well, you want to kind of take that with a grain of salt, because who says they're any good at doing this certification? So then, any third party may come along and say, well, I know something about cyber, I'll certify you. Well, that ain't good either. You want, if you're going to a dentist, you don't want a dentist that's just read a book about dentistry. You want a dentist who's been certified in dentistry by some independent authority. So that's where the accreditation of a certification body becomes important. They make the certification body credible because there's an independent authority looking at that certification and saying, okay, that certification body does things well, they follow the standards. Now, in the United States, this is the ANSI organization, American National Standard Institute. So they certify all kinds of products and systems and environments within the United States. ANSI is in our office a couple of times a year looking at the competencies of the individuals who work on certification projects, how we document our knowledge about the standards and how well we run things. And ANSI belongs to what's known as the International Accreditation Forum. So this is an international body that consists of organizations within countries all over the world that are like ANSI, that certify local certification bodies. So we can trace our knowledge and our certification, our capabilities, all the way up through an international organization. Here are some notes that we get from the international bodies. There's a specific, you see the ISO standard there, 17065. That's what ANSI uses to certify exida, and should be any organization that you work with in terms of certification should satisfy the standards of the organization within your country. So in the United States, we use the ISO standard 17065. They're equivalent standards for other countries around the world that are part of the international accreditation body. So what I'm trying to emphasize here is that it's very important that a certification body that you rely on have the proper credentials and has independent proof, or you have independent proof that you are an organization that knows what they're doing. Yeah, and this is just another slide that shows this is the certification of exida. You can see the document on the right and all of the various international standards that ANSI has said we are certified to do. ISA Security also is an organization with the United States that we work with in terms of security certifications. So we've been certified also by this ISA Security group. They have their own security certification schemes and standards like 62443. Although they are now have evolved to be compliant with 62443, we've worked with them for many years on certification also. Certification can take a variety of different forms. Very often, organizations will be very interested in getting their internal processes certified. So if they're developing a series of products, they can get their process certified, which then makes the certification of the individual products that they build and design under that certified process much easier to then turn around and certify. Device certifications, like in the automotive industry, we've worked with certifying braking systems and vehicle motion detection systems, LiDAR systems, and the like. System certification is another type of certification at a little bit higher level. This is more from an end user standpoint, showing that they continue to operate their equipment in safe and secure environments. And then we also work with personnel certification. It's very important that people who work on cyber, automotive, security type projects know what they're talking about. So there are various certification programs that exist that will identify and assure certification of individuals. So therefore it shows that they are competent to work within that particular environment. The process itself basically consists of going in, assessing the so if you came to us and said, look, we want to get our processes certified, we'd take an initial look at some of your documentation, give you some sense of what gaps there might be between what you do and what the standard says. You close those gaps, and then we'd wind up coming back and doing a little bit more detailed certification. In the case of a product, we'd also perform network testing or robustness testing on that individual product. These are various certification schemes that exida provides, not only process, but systems and personnel. You can see the presentation will be available, and you can please stop by our exida booth if you have any questions concerning those. Within the 6443 standard, they identify different kinds of devices that can be certified: embedded devices, network devices, host devices like a host server, and actual applications themselves like operating systems, let's say. So certification, the standard identifies many different types of components that can be certified. In terms of benefits, from an end user perspective, knowing that your system adheres to these standards and is robust is certainly a tremendous advantage. And not only that, it's a market differentiator. If you can say I'm security certified, then that shows that you follow good processes in your product development and you've built in the necessary functionality to keep your products mature, protected against breaches. From a supplier perspective, if they're secure, then typically this evaluation process only needs to be done once. So end users will often specify, just in their original request for a quote on a system, that you must have all certified products. So it's good from many perspectives, an end user and a supplier standpoint. There are a number of different standards that are security related. Most of them refer back to 62443. Within the automotive industry, there is a new standard which is being developed, 21434. There's initial releases of that standard that occurred in 2019, and it's expected to come out in 2020. So this will be, I don't know, I haven't been able to find out what kind of harmonization is occurring between the developers of this standard and the existing 62443 standard. I imagine there's communication there. I just couldn't find any specific identification of it. One of the key things that that standard is going to look at, you'll see, is the threat modeling. Threat modeling is a design analysis tool that looks at your system basically from the standpoint of a hacker. How can I break into the system? And if I can identify ways I can break into the system, I can build in mechanisms that hopefully will secure that better. Personal certification in integration, automation, software, design and operation in robotics. We also have one in automotive. So this is, these are based on 62443, but they're derivative certifications based on a particular industry. So this is a way that you can demonstrate your knowledge and your capabilities as you work within a particular environment. So if you're interested in learning anything more about the systems and about the kinds of things that Exida provides, if you want to get a better understanding of what the value of cyber certification is, Sudhir Pai is our main contact here in India, and he can answer any of those questions. So I haven't heard a bell yet, so I guess I still have a little bit of time, so I'd be glad to entertain any questions that you might have. Anybody had a cyber certification done on their system? Who here is cyber certified? None of their products? It's a good idea to do that. Well, thank you very much. I appreciate your attention. I hope that I've been able to give you some insight here.